Hey yo guys, today I'm just to be doing some, as you can see, differential equations for work. But at the same time, we'll be teaching differential equations. Just so, yeah, it's just a step-by-step process. The same thing every time. Okay, and a lot of the stuff that you learn in maths is the same thing every time. So I mean, if you get it wrong every time, it's probably because you don't know how to do it. So just know how to do it really. And it literally, I don't think this doesn't really have any application in real life. I mean, if it does, then I don't know how people get into these dodgy situations where they need someone to solve these questions. But yeah, I'm gonna get straight to it. Got my phone booklet ready right here. I'm fine using phone booklet. Um, yeah, I'm gonna get straight to it. So basically, this question right here. Okay, I clicked an option because it was an accident. It doesn't even click, unfortunately. But yeah, basically this is a homogeneous differential equation because they gave me a substitution. Basically, right? You see when you like derive, let's say I got y equals x squared. I derive that, or it's just be like dy by dx equals 2x because respect to x both sides. Okay. What if I had like dy by dx? Okay, don't ask why I'm starting with that, but it's just yeah. That basically just saying derivative is equal to x y. Let's say I want to know like what the solution to is, like what function y makes this work basically. Um, and what you can do is you can like separate the dy and dx's. So you basically want all the x's on one side, all the y's on one side, and integrate both sides. I'll show you. This is just an example question, just for it. Equals xy dx. So yeah, it's by the these are just constants. I know you can just make them like you can turn y into dy by dx, but it's just a fraction. Okay, think of it as like 2/3. Okay, so you don't just stick it there. And then you can times by y both sides. See what I did there? And then if I integrate the right side, I'm gonna get x squared over 2. Integrate the left side, that's just ln y, and put plus here. So then, like, if you do e to the everything to the power of e, this is e to that. And for this part, it's going to be e to the c, and e to the ln y is just y. Y equals e to the x squared over 2, and y equals e to x squared over 2 over e to the c, and that's the same as this. And that's the general solution. That's how it would be. So basically, all I did was literally get the y's x on both sides. Um, problem is, for like, let's say I want to do this for this, x plus y squared. Unfortunately, like the x and y are not stuck together, but at the same time, it's really dodgy the way you do this. So we gotta use substitution, and then you'll see after like what happens. Okay, nice things happen, I think. Um, so for here, it's telling me to use they also give you substitution. So I mean, if they give you substitution, you're probably gonna put it in. dy by dx equals v squared. The problem is now I gotta like change dy by dx into something in terms of v, because then we can solve for v. I think of v like is let's think of this as like we'll make like a new question basically. We went from that to that. And what's gonna happen is once you get the answer, you'll sub in back v for x plus y, and you got your solution. So for this part, if you take derivative of both sides, because I want dy by dx, right? With respect to x, v is just dv by dx. X with respect to x is just 1 because it's x itself. That's dy by dx. We solve for dy by dx here. dy by dx equals 1 minus dv by dx. Oh, sorry. dv by dx minus 1. So then dv by dx minus 1 equals v squared. dv by dx equals v squared plus 1. You can switch fractions. Remember I said you get one variable on one side and one variable other and integrate. So 1 over 1 plus v squared dv equals dx. This is just x, integral of 1. Integral of this part. Now, let me just got my formula somewhere there. Well, the integral of that is arctan x. So that's arctan v plus c. And then we're just going to solve around. I see. Take tan on both sides. V equals Actually, wait. Yeah, you go first. And then now, v, what did we say v was? X plus y. So y plus x tan x minus c. Y equals tan x minus c minus x. And that's that. Okay. I do have some of these questions here I haven't learned how to solve. Okay, I can do that. But yeah, I hope you kind of get this. But bye guys, just so you know, since I'm pretty like fast in maths, I might like start look at like competitions and I might like post on YouTube like how to solve things really fast. I might give like techniques because I am fast, so might as well like show like instead of saying I'm talented, I'll actually show you how to also be fast because you know it's a nice thing to do. And yeah, that's it. That's just a little shot. Okay, next one. Okay, this one I don't think you need a substitution. It's x y. I think for this you should do. Let's see. Uh, if we divide by oh, like I said before, you see how when you want to make it so x and y is both sides. I think you can do that here. Let's try it. If we divide by times by dx on both sides. See, this is how you just visually look at it. See, look, think of math equations. You could just do anything to them. People don't. Some people would look at a question, they're like, "Oh, I can't do the concept." You can literally do anything. Just follow the rules, and literally, you could like times by 5 on both sides here. Did you change anything? Nothing changed. But it's just inefficient, so there's no point doing that. And then now maybe if I get the y on the other side, so divide by y like that, I just divide by y, and divide by x squared plus 9 on both sides. So 1 over y dy, x over x squared plus 9 dx. Notice how I here, this is just learn y plus c. For this one, reverse chain rule, it's going to be, you look at derivative bottom, it's 2x. We want a 2 here, so times half here. So we are half learn x squared plus 9. And that's it. Anything we do? I think we can do e to the both sides, just like before. It's e to the c y. Oh, yeah, let me just visually show it to you. This is the same as e to the c times e to the ln y, because it's the power rule thing, is equal to e to the ln root x squared plus 9. If we did this part's just y. If we divide by e to the c on both sides, it's going to become e to ln root x squared plus 9 minus c. I hope that's somewhere here. Oh wait, okay, they didn't do the e thing. Wait. I guess here we can do. What would you do? This part's ln, right? Yeah, and there's a half lateral. Okay, that's fine. That's awesome. Maybe this part I know is ln root x squared plus 9 minus c. Take e to, oh, as you know, take e to everything. This part is just y, which equals root x squared plus 9. That's somewhere there. Yep, that is somewhere there. And then e to, so, just see. That's just a constant. 1 over e to the c is a constant. I don't know if you guys can see that. Maybe if I do this. So therefore, y equals a root x squared plus 9. Which is, what, number 4. Okay, sorry. I was trying to do the e thing, but I think I did a mistake somewhere. But you see, you go back and do it again. You see, this is why I'm doing this stuff like mostly first try, because I just want to reiterate that thought, okay? No one's perfect, but just, okay, the person who, if you see here, why is it spelled home o work? You see, look, I'm not the only one making mistakes, okay? But it's fine. See here, like, this part, I think Yeah, I think what I should have done is just look at the answers and just see. Most of them don't have an exponent, so let me just like sort of get y ln y by itself, so then e to ln y gets c on the other side, and should be good. Okay, okay. I don't think. Yeah, I've not done Euler's method, so I can't do that. Find gen. Ooh, see, a lot of this is this differential equations. You see how it's just the same step each time. I think don't ever get confused about what's asking. You can literally, I say, just play around before you get straight into it. Just play around with it. But if it's like the first time I've revising stuff, we're not revising, just doing a homebrew. Um, oh, it's another one. It's not a boring one because this is just y squared dy equals cos 3x dx. I also have to be careful here. Integrate both sides. You add 1 to the power and you divide it. Plus c. Cos 3x. What's the integral of cos sine? But yeah, it's going to be a third sine 3x. That's it. Yeah. Then we could do y cubed over 3 was a third sine 3x minus c equal to sine, because that has 3 both sides, 3 and a third cancel, minus 3c. You can still let this be c, because c is just a constant. Times by 10 is still constant. Unless you times it by x, for example, or y, if that's part of the question, you keep it like that. You take cube root of everything. So cube root sine 3x minus c. And is that anywhere here? Okay. Make plus c. Wait a minute. What's the integral of cos? I'm not making a mistake here. Yeah, integral cos is sine, no? And then you just divide by the inner part. So how did they? I'm pretty sure that's the answer. But then there was a plus here for some reason. Or maybe they had the plus. I don't know. Maybe they're using this the constant for here, because then that makes sense. Okay. For some reason they did plus 3c, but my teacher told me not to. Okay, I'm being lied to here. But you know, fair enough. You see, and I guess that looks like one of the answers. See, you don't have to be perfect. Just make sure you're efficient. Oh, okay. This is calculator. 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 Damn. Uh, I think I'll do one final one here. One final example. I'll give a sort of a strategy. This is calculator. I don't have it. So, is there any like hard ones? Okay, these are easy. These is easy difficulty, by the way. Fair enough. Let's see. The particular solution on the interval x of a differential equation that satisfies y1 equals 1. Let's show that this solution satisfies. The implicit equation this solution satisfies is. What? Okay, I don't even know what I was asking. I might stop here though. Yeah, there's actually nothing else. Sorry. Well, that's all gonna be it for today. To be fair, yeah, I think that's pretty much it for differential equations. I mean, I could give you a little conclusion for today. Um, remember, whenever you're differentiating, here's the types of differential equation. Okay, this is normal. Let's say y equals 2x. Differential of that, y equals 2. Okay, this is a bit harder. Let's say I don't know, y. Hmm. hard. Maybe let's say I told you v equals xy, but problem is these are all functions. So y is a function, x is a function, v is a function. To differentiate, let's say with respect to time. Okay, the respect time, just think of it as like a graph, and you got time on the bottom. Okay, when you take the rate of change in x is just change in t, and that way like change in v, for example. Therefore, this would be dv. D by d is delta, which means that dv over dt equals. Now this would use a product rule, so u prime v plus v prime u. Just always remember this: u prime v, so derivative of x, so dx by dt y plus dy by dt x. For example, you could do like that. This could be a way if you ever get a question like that. And I guess a bit more harder. If you have, for example, now we're looking at differential equations. Where, like, for example, maybe y squared. This is similar to what I did before, but there are questions where they ask you to use, before the substitution this, they could ask you b equal y over x. I could solve this now, to be fair. Dy over dx equals 2 lots of y over x squared. Basically how these questions work is they give you substitution. They would, but unlike before, it wouldn't actually be in the form of a substitution yet. You gotta like sort of find it. So here I noticed, I made this question off, like ran off to dome, by the way. I took the 2 out, it's y squared over x squared, which is y over x squared, and y over x is v. So it fits nicely. V squared. And then, like before, y equals vx. Now we got to do that implicit differentiation. So dy by dx is equal to product rule dv by dx x plus dx by dx. So that's just 1 times v. So let me just bring this here. Dy by dx is dv by dx x plus v equals 2 squared. Yeah. Wait, let me just make sure that's correct. Just of v prime plus. Yeah, that's fine. dv by dx x. Okay. For some reason, x is not in terms. Basically, everything's supposed to cancel out. Nothing's cancelled out. So unfortunately, I gave a I guess this example doesn't work. I guess probably because you could separate it and on both sides. Oh well. See, this is another important thing. Once you get used to maths, you can tell when things go wrong, and just fix them. Okay, don't waste your time. I think back in the day, I could probably get pissed if like I don't know, it's like doing a problem and you thought you were right, but then you realize everything was like wrong. My whole method's wrong. There's a way easier way, for example. You gotta just accept it. And then one day it's just normal. You like literally, and then you get satisfied when you realize. That's it. So anyway, guys, that's a little lesson on life. Thank you for watching. Hope you have a a very nice day. Um, by the way, there's a Discord channel in the link below in my description, just in case you do some maths. Yeah, come to the channel. We're open-handed for anyone who's like really good at maths or wants to be really good at maths. You come to the right person. Yeah, please make sure to like, subscribe, and have a good day.